All right, important lecture coming at you. We're going to talk about the DAX calculate function. Now, calculate is arguably one of the most important DAX functions of all because not only does it do pretty powerful things on its own, but it also serves as a container for much more sophisticated and complex DAX formulas. So let's break this down. Calculate on its own, pretty straightforward. It evaluates an expression or formula under a set of defined filters. So here's what it looks like. You've got your expression argument first. This could be the name of a measure, or it could be a DAX formula that could create a valid measure. So you could plug in your total orders measure there, or a sum function of the return quantity from your returns data table, both totally valid options. And then the second component of the function is this set of filters, this list of simple Boolean, meaning true, false, filter expressions. Now, important thing to note here, these must be simple expressions with fixed values. So column name on the left and some sort of a value or text string on the right, separated by an equals, a greater than, a less than, etc. So some examples could be country column from territory lookup equals USA, or the year column from the calendar table greater than 1998. What you cannot do here is insert more complex filters or even use filters that reference measures. So again, column name and some criteria, either value or text. So pro tip here, the way that I've kind of wrapped my head around calculate as I learned it for the first time was to think of it in Excel formula terms. I'm obviously an Excel guy, that's my background. I think like Excel, so anytime that I can relate it to something comparable in Excel, that usually helps me kind of wrap my head around it and understand what's really going on. So calculate works very much like a SUMIF or a COUNTIF or an AVERAGEIF function in Excel, in which case you're evaluating a sum or a count or an average if certain filters or criteria are met. The difference is that calculate can evaluate measures based on any sort of calculation, not just those restrictive sums, counts, averages, etc. So you can almost think of this as like a calculate if, which is much more flexible because you can define really rich, really complicated measures and plug those into the expression argument here in the calculate function. So I want to jump to Power BI, do a simple demo, and then return to the slides to dig a little bit deeper into how this is really working. All right, back in AdventureWorks report, let's try creating our first ever calculate measure. And this measure is going to be related to my sales. And what I want to do here is calculate a measure that captures bulk orders. So in other words, I'm going to evaluate the total orders measure that I've already created, but only under the filter expression where order quantity is greater than 1. So this is a good candidate for calculate. Let's right click, add the new measure. And I'd like to name this one bulk orders, even though realistically an order size of 2, you could argue isn't really bulk, but let's not worry about that. So bulk orders equals calculate. First argument is my expression. So what am I calculating here? Well, I'm calculating my total orders measure that I've already defined. And then comma over to my filter statements, my filter expressions. And in this case, I'm looking for cases where my order quantity, which is AW sales order quantity, is greater than 1. Close the parenthesis. So this should check out because I'm evaluating a measure called total orders, and I'm calculating that measure, but only if my order quantity value is greater than 1. So we can press enter to lock it in. We see our bulk orders measure now defined. And let's go ahead and select our matrix here. I'm going to pull out our return fields. And I'll pull out average retail price as well, so that I've just got quantity sold, total orders, and now bulk orders as well. So it's interesting because you see a lot of bulk orders as a percentage of total for things like accessories and to a lesser extent clothing, but you see no bulk orders for bikes, which makes sense. If bikes are a much more high ticket item, you generally won't have customers coming in and purchasing multiple. So that looks good. That's our bulk orders calculate function. Now let's return back to the slides and drill in a little bit deeper into how this function's working. So let's look at a different example of calculate here. In this case, we've defined a new measure. We're calling it bike returns, which uses calculate to evaluate the total returns measure, but only when the category name from the product table is equal to bikes. And when you visualize this bike returns measure against your total returns, broken down by category names, you see something interesting taking place here, which is that you see the same repeating values in every single row for every single category name within that matrix. So you may be wondering, shouldn't those cells have different filter contexts in the other rows for the clothing row, for the components row? And this leads me to a very important point, which is that what calculate is actually doing here is it's modifying and overruling any competing filter context. Now let that sink in for a minute. Let's pay attention to the clothing row, for instance. That clothing row in the matrix has filter context of category name equals clothing, which is defined by the row label, and it also has filter context for category name equals bikes, defined by the calculate function. And since both can't be true at the same time, the clothing filter is overwritten and the bikes filter from calculate takes priority. So think of calculate as kind of the bully function or the bully filter, which says, I don't care if I'm sitting here in a matrix row that says it should be calculating accessories or clothing or components. I'm the boss. I'm going to step in and say, we need to calculate for category name equals bikes, period. And that's why you see the same total row after row after row, even for lines like components, which didn't generate sales or returns. Now, it may be helpful to revisit the step-by-step measure calculation that we walked through earlier in this section. So remember, there were 3 steps there to every measure calculation. It started with the filter context being detected and applied. So in this case, we're looking at the accessories row in that same example. So Power BI says, okay, we're in the accessories row. The matrix row labels have passed us filter context that says product category name should equal accessories. So go ahead, head to the product table and filter that down to just accessories rows. Here's where things change. Before we move to step 2, where normally that filter context would pass down to any related data tables, there's an intermediate step, which is that the filters get modified by calculate. So anytime the measure being evaluated, in this case bike returns, contains a calculate function, that filter context gets overwritten right here between step 1 and step 2. So what's happening is that even though we originally filtered down that product table to accessories, between step 1 and 2, the calculate function butts in and says, nope, we're actually going to filter based on category name equals bikes. And then that new filter context passes over to step 2, and the process continues as it normally would. So now the filter context is for product rows where the category equals bikes, and that context passes to any downstream connected data tables, and from there, the measure is evaluated. In this case, the total returns, which is the count of rows from that final filtered returns data. So the point here is that no matter what that initial filter context was in step 1, defined by the matrix row labels, accessories, bikes, clothing, or components, regardless of what it is, it's going to get overwritten with bikes, and then everything from step 2 onward yields the same end result of 342, and that's why you see the repeating values. So definitely a tricky, pretty technical concept, but let's head back to our report and create a function like this so that we can kind of see it working for ourselves. Okay, back in the report, first thing I want to do is actually jump to data quickly, and I want to create a measure to capture weekend orders. It sounds like our AdventureWorks clients are really interested in sales trends between weekends and weekdays. You know, maybe they're looking to see if they need to run more offers on weekends to promote sales, or if weekends tend to be stronger than weekdays. So to help them answer those types of questions, let's use a calculate function to evaluate our orders measure, but only for weekends. So we're going to be basing that off of this weekend column that we created with our if and or statements here in the calendar table. So let's hop back to our report view. And again, this is going to be a sales related measure. So I'm going to right click, add the new measure, and let's name this weekend orders and set that measure equal to calculate function. And we're calculating total orders, our measure, where the filter is that the date is a weekend. So we can search for that weekend field. There it is. And the two values that weekend can take are weekday or weekend. So in this case, my filter will be weekend and close it out. So we've got our simple filter, column name, criteria, and I think that should just about do it. So when I press enter here, created our new measure for weekend orders. I'm going to select my matrix, pull weekend orders in, and to clean things up a little bit, let's pull quantity sold out, bulk orders out, and let's clear all of these product related fields as well. So we should just be looking at two numbers, total orders and weekend orders, which is calculating the total orders measure, but only in cases where the date falls on a weekend. So just like I showed you in the slide, let's go into our calendar lookup, grab that weekend dimension, pull it into our rows, and this is exactly what you see. That same repeating weekend order number over and over and over again. Now you might be wondering, what's the point of calculating a weekend order specific measure when you have access to this weekend field that you can pull in, to break down your orders exactly like we see here? Well, the answer is that if we weren't filtering on this weekend field, pull that out of our rows and pull in any of these other fields like category name, for instance, we're still able to see the weekend specific orders broken down in a completely different way by category without having to have that weekend dimension pulled into my matrix view. And not only that, but just like any other measure, this weekend orders measure can now serve as an input and be nested into other calculated measures from here. So it gives me a lot more flexibility than I would have if I were simply pulling in a dimension like weekend and breaking down a basic total orders measure that way. So that's your primer on the calculate function. In the next few lectures, I'm going to talk about how to make this calculate function even more flexible and even more powerful by nesting other filter functions like filter and all. Stay tuned.